Okay. For those of you that read the email, everything in the email is correct. You misinterpreted the email. You have something to turn in tomorrow on the first derivative test. It's not a test that you're taking tomorrow. It is a homework that is going to be turned in, and the name of the homework is the first derivative test. All right? Same thing for the Wednesday. You have something to turn in on concavity and the second derivative test. Those are not tests to take tomorrow and Wednesday. So those are your two assignments that you've got in addition to the web assignment that's due tonight. Also, you have we do have a test, a real-life sit-down-and-take test Friday week, November the 1st. It will be just a 1-hour test. It's only probably 15, 16 problems, probably no FRQs, all multiple guess. So that's kind of where we're headed with this here. But for today, I hope you've downloaded 19, the first derivative test, so we can begin talking about what this is. Now, this is still tying in some of the same stuff that we've been dealing with. Remember that before we talked about mean value theorem and Rolle's theorem. What do those two things say? Does anybody recall?
You have to hit a certain point within a certain frequency.
Okay. All right. So, if you're looking at how high 2 points are, Rolle's and MVT say if I'm looking at, it's not. Pardon me. He doesn't know who I am yet. Still doesn't know who I am. Come on, figure out who I am. There we go. That's who I am. Okay, you will have time next hour to freak out over the web assignment that you haven't looked at yet, okay? So try to focus on this. But remember, Rolle's and MVT say if we've got a function, and this is a beginning point of the function, and there's an ending point to the function, if the function is continuous and differentiable, then if we can figure out the slope of this line, there has to be at least one other point where the slope is the same as that. All right, now is that Rolle's theorem or MVT? Okay, this is it. That's right. This is MVT. Rolle's theorem is almost the same. What's different about Rolle's theorem?
The 2 points are on the same.
All right. The only difference when we move over here to Rolle's theorem is with Rolle's, the endpoints are the same. So if the function starts off being at this place and ends up being at this place, then there has to be some place where the derivative is what? Where the derivative equals 0. Okay? But again, for both of those, we have to talk about continuous functions. The functions have to be continuous. They have to be differentiable. Okay? Now, today, we're going to talk about something that initially, yes, ma'am.
My Moodle doesn't work and mine's not working.
Okay. Settings. All right. Sometimes cutting this off and setting it back on, or you may have to restart your computer. Restart the. Yeah. Okay. So let's talk about. Let's look at this, and Amanda, you keep trying to download that. Look at this picture and answer these questions. Talk to a buddy. Talk to somebody close to you. Write down what you think are the answers for these. On what intervals is this function increasing? On what intervals is it decreasing? What are the coordinates of the relative max and relative min? When we're talking about intervals, we only need the x coordinates of it. Yes, something could be infinity in this here. Because we aren't giving you any specific endpoints, so we're going to assume that the ends keep going in the direction that they are going now, okay? Okay. So, Katie, where is this thing? Give me an interval where it's increasing. Brackets like this? That sounded like a question. Was that a question? It wasn't? Okay. Or you're saying no, it wasn't a question, or no, it shouldn't be brackets? You don't think it should be brackets on both sides?
I don't think either of them should be brackets.
Okay, so you're saying instead of that, you're saying it should be this, Connor? Okay.
You can't have a bracket with infinity because it never reaches.
Okay. So you're saying it should be both parentheses. Okay. Brackets. A bracket says it's included. A bracket says that it stops right here. Okay. So, which infinity doesn't stop. Okay. So that's one of those things I'm not sure we've ever really talked about. So you can't have a bracket at infinity. So it's got to be a parenthesis there. Now, what about at -2? Look at the question. Is it, all right, but is the function increasing at -2? It's just there. It's not increasing at -2. It is stopped. So the correct way to write that is with just the parentheses. It's from -infinity to -2. And you didn't really know that, so it's okay if you didn't get there, okay? So -infinity to -2. Jason, is there any place else that this thing is increasing?
Yes. From 0 to
0 to infinity. And we've got parentheses on both of those, okay? Where is it decreasing at, or is it decreasing anywhere, Jacob? -2 to 0, okay? All right, coordinates of the max. I want an x and a y coordinate. -2 is the x right here. -2, comma, 0. And it's a relative max, and we'll try to clarify that in a minute. Are there any other relative max? We don't say infinity. Infinity's not a max, but so then no. Okay. So what about a relative min? Do we have one? 0, -12. Okay. So we've got a relative max and a relative min. Now, what analogy did we use the other day for relative? What? That's not the example we use. I'm not sure. Does anybody remember? The gas station, okay? The QT is the lowest place around, but it's probably not the lowest in the area. You know, I went through Milledgeville and to Macon on Saturday, and it was 309 down there, so it's cheaper down there. So I'm not going to drive down there to get gas, but it's cheaper there. But the QT is the lowest place in the area, okay? So that's what it means to be relative, okay? Does this function have an absolute max or an absolute min?
No.
No. That's right. Since it's infinity, we never get to some place that it stops, okay? Because as soon as you tell me this is the highest, I can go one more to the right and it's higher. Or as soon as you tell me this is the lowest, I can go one more to the left and it gets lower. All right. Now, I have a question for you. How did you figure out that the function was increasing from negative infinity to negative 2? You looked at it. Because you looked at, well, good question. How do we know it's not decreasing?
From the right, it's increasing,
Because
from
of
the
the
left,
left.
it's increasing.
We always look at it from left to right. Just like we read English from left to right, we're going to look at it from the left to the right. So it's increasing as we go from left to right, okay? But, so you looked at the function. Well, what if I didn't give you the function? What if I just gave you this and said you can't graph it? And I said, find the interval where it's increasing. Actually, it's a lot easier.
Either either.
Why?
You have to find where the derivative is 0.
Okay, now Sam said you have to find where the derivative is 0. Why is that important?
You can do roll zero.
That's when it's
All that jazz.
Okay. So, all right, Sam Chase is here now. Where is the derivative 0 in this picture?
-2, 0, and 0.
All right, and this is an important concept for y'all to understand because it's important from now till May. All right, at these two places, it's 0. Okay, does everybody see that? Now, describe the derivative before x equals -2.
You just go like 20 minutes.
Describe the derivative. Okay, I heard positive. I heard negative. Okay, think about the derivative. If I draw the derivative right here, what's true of the derivative in every case? It's going up. So the derivative is always positive. And what's true of the function when the derivative is positive?
Negative.
No, not okay. All right, let's don't go there yet. Okay, so the derivative is positive here, and the function is increasing. Okay, use one word to describe the derivative from -2 to 0. Negative. The derivative is negative in here. The derivative is less than 0. Okay, and what one word describes the derivative from 0 to infinity? The derivative is positive. Okay? So, by looking at the sign, S-I-G-N, of the derivative, you can tell whether the function is increasing or decreasing. Agreed? Because the derivative is positive, we know the function is increasing, we know the function is going up. When the derivative is negative, we know the function is going down. When the derivative is 0, we know the function is not changing, it's sitting still. Normally a derivative of 0 is only 0 at a particular point, like this point here and this point here. So suddenly, look at what we can determine by simply knowing the sign, the positiveness or negativeness of the derivative. We can know something about what direction the function's going. Do we know where the function is? No. The derivative is positive over here, but the function's below 0. The derivative is positive over here, but the function is below 0 and above 0. So we don't know anything more than that. But now let me ask you something. Does this function here ever decrease anywhere else?
No.
How do you know that?
Because it's not cubed.
Okay, but how do you know if we zoom out enough that this function doesn't somewhere way over here turn over and start going down? because it goes to infinity, but still it could go up and down, do this, and then wind up at infinity. How do you know it doesn't do that? That's going to be hard to see on the video. I don't know that Brandon can see that on the video when he looks at this later, but I was waving my finger, Brandon, up and down. Okay, but unless we expand out, we won't really know that the function keeps going up and down looking at the picture. How do we know up here, looking at this, that the function never turns over and starts going back down? There's only two x-intercept, but the x-intercept, it could do like this, up and down, and never go across the x-axis again. Take the derivative of this function. Take the derivative of f of x equals 3x squared minus 3x cubed minus 9x squared plus 12. We get 9x squared minus 18x. That's our derivative. Okay? Now,
The bigger the x, the higher it never becomes negative.
set that derivative equal to 0. If we set that derivative equal to 0, an Algebra 2 student can solve that problem, so I expect y'all to, okay? How many answers do we expect to get? 2. So we get x equals 0, we get x equals 2. So what does that tell us? The derivative is 0 when? At 0 and at 2. Then that's the wrong function. Yep, that's the wrong function. Should be a plus there. Okay, should be a plus there. So that would be a plus down here, which makes this a minus here. So we got that the derivative is 0 at 0 and negative 2. Well, those 2 points are on our graph. So answer me this. Could this function somewhere over here greater than 0, does this function ever turn over and start going down?
No.
Why not?
Because the derivative has to be 0 when it turns over.
If the function is going to go from increasing to decreasing, somewhere it has to be 0. But we know it never turns 0 again. Unless it's discontinuous. And if we look at this function, very good thought, if we look at this function, it's a polynomial. What are the times we have to worry about discontinuities? Fractions, piecewise, logs, square roots. Fractions, piecewise, logs, square roots. Do we have any of those in this equation here? So we don't have to worry about discontinuity. So then we know beyond a shadow of a doubt that this function keeps going up. It's never going to turn over. Okay? And we know that not because we're looking at the picture, not because we're relying on the picture, but because of the algebra, because of what we can figure out by looking at this function here. So I want us to go over to this next picture here without graphing. Without graphing, find the intervals on which this function is increasing and decreasing. Okay? Now you're kind of coming up with your own set of rules here based on what we just did. What's the first thing we need to do in order to figure this out? Find the derivative, set it equal to 0. So the first thing we're going to do is we're going to find f prime, set it equal to 0, and we're going to solve it out, okay? You're smart people. You can do that. I hope I made this one up right. I did. Wrong. Did you miss this negative sign right here? It's easy to miss that there. Oops, I shouldn't do that. Might wind up throwing away an answer. I would even factor out a negative 6. So I got 2 places where the derivative is 0. Is that what y'all got? Now, if I'm solving this problem now, I'm going to do the next thing that I'm about to put up here every single time, okay? This is something you need to get into the habit of doing. It's going to make your life lots easier. I'm going to write it out in factored form because of what I'm about to do, okay? I think this is by far the easiest thing you can do to solve this type of problem now. Second thing I want to do is I'm going to create a sign line. You're going to create sign lines over and over the rest of the year. They're going to be very important to you. A sign line, we're going to draw a number line. Okay, we're going to label this number line as F prime because later on in problems we might have 2 or 3 sign lines in the same problem. So this is a sign line for F prime. On F prime, I'm going to put in my 2 zeros for F, -1 and +1, okay? Now, it's important that we write down all of the factors of the derivative, okay? I'm writing down all 3 of them. If you leave off that -6, you will miss this problem. Guaranteed to miss it. Now, let's talk about why we're doing the sign line. Remember on the picture that we did, remember on the first slide, we said we knew where the derivative was 0, and it was always increasing or decreasing between those 2 spots. How do we know it has to have the same sign between them? How do we know that the function can't go from being down to back up between these 2 here? There'd be another 0. We don't have another 0. So what we need to do is we need to figure out what is the sign of F prime to the left of -1. Pick any number less than -1. -2 would be an easy one. When I put -2 in here for x, is -6 positive or negative? Negative. -2 minus 1? Negative. -2 plus 1? Negative. What do I... It's any number to the left of this number right here. There's no place to put it in. So it's just -6. This -6 is always going to be a negative number. Okay? Now, what are we going to do with -6 and x minus 1 and x plus 1 to get the derivative? These are 3 what of the derivative? They're factors of this derivative. So how would I get back to this thing that I've got written up here as the derivative from these 3 things here? I'd multiply them together, right? So if I multiply a negative times a negative times a negative, I get a negative number. All right, we're going to do the same thing between -1 and 1. What number are you going to pick? 0. 0 minus 1 is negative. 0 plus 1 is positive. So the function is, the derivative is going to be negative times positive is going to make it positive. All right? Bigger than 1. 2. The -6 is still negative. 2 minus 1 makes it positive. 2 plus 1 is positive. So negative times positive is negative. So in your mind, you should be able to tell me, where is this function increasing? Where is the function increasing? -1 to 1, I hear negative infinity to -1. Okay, negative infinity to -1 has been withdrawn. How do I know the function's increasing from -1 to 1? Because what's positive? Not it's positive. The derivative is positive. It's important for you to get your wording right here, okay? Because we're going to have so many things running around here. It's important for you to say the function f is increasing from -1 to 1 because f prime is positive. Okay? Pronouns are going to mess with your mind in here, okay? So it's very important that you be specific. F prime is positive. So where is this function decreasing? And why? Negative infinity to negative 1 and 1 to infinity, okay? F is decreasing from negative infinity to negative 1 and 1 to infinity because F prime is negative. Okay? Now, you've written it down, but do you understand it and does it make sense? Close your eyes and in your mind picture what this function has to look like. What's happening from negative infinity to negative 1? What's the function doing? It's increasing. What does that mean? It's going up. Okay? So let's see if we can kind of draw. That means the function's got to be doing this, doesn't it? Now what happens when it gets to negative 1? It stops going up and it turns and goes down. Right? Is it the other way around? Oh, you're right. It's decreasing. I'm sorry. F prime is negative, so the function's decreasing. It's going down, and then at negative 1, it starts going up. And what happens when we get to 1? It starts going back down. All right? Bless you. All right? Does it ever start going back up again? Never. It's going to do. Can you tell me where the max and the min are? Can you? You said at negative 1 and 1. How do you know that? Which one's which? So is this a max or a min? This is a min. And this up here is a max. Okay, so now do you realize that you just discovered how to find out the max and the min and you have to draw a picture of it? How do we know that this is a minimum? Because what was the function doing? The function was going down. We know that the derivative is 0, and then the function starts going up. If in your mind or in real life, if you can just picture, I really like taking something and holding that in front of me. Going down, it bottoms out, it becomes 0, and it goes up. That point has to be a minimum. Okay? We have no earthly idea. Okay, but we'll figure that, we'll show you how to find that in a second. But all we know is that this is a minimum. Okay? Just think about it this way. If you're looking to buy the cheapest gas in town, all you care is that it's the cheapest. You don't care what it is, you just want to know where it's at. Okay? So all we know is we know that the minimum gas can be bought at QT. We don't know what it is, but we know it's cheaper than anywhere else in town. So think of it that way. That's all we know. We know the cheapest place is right here at negative 1. The lowest place. The highest place is over here at positive 1. Okay? So, suddenly, without drawing a single picture, you can tell me where the min is and where the max is. All by looking at this sign line right here. Look at your sign line. Go back and look at what you drew up there, okay? The derivative goes from negative to 0 to positive. That means that this point is a minimum. The derivative goes from positive to 0 to negative. That means this point is a max. Could it be positive, 0, positive? Ooh, that could be pretty. Grab your new piece of paper somewhere, all right? I'm going to give you a sign line. Let's say 1, 2, 3, 4. And let's say positive, negative, negative, positive, positive. Fine. This has absolute, I just made this up off the top of my head, okay? There's the sign line for the derivative. of a function, okay? I want you to tell me where the max and the min are. I'm not giving you any function to go with it, not giving you any picture to go with it, but picture in your mind or sketch on paper what's going on here. Talk about it with your friends there. See if you can come up with some solutions. We'll come back and talk and discuss it here in just a second. What do you know? All right. Well, then what on earth is happening at 2 and 4? But we know it becomes 0. It's got to be 0 there. So what does it look like is really what I'm asking you, okay? No, we know it's continuous. Wow. Wow. Okay. You said this is a, what'd you say? All right. Connor says this is a max, says this is a min. Okay. But 2 and 4, now they are zeros there. I told you that. The derivative is 0 at 2, the derivative is 0 at 4, but they're neither maxes or min. So who thinks they know what the picture has to look like there? You think you do? Almost, but the derivative could be 0 here and here. Okay. Here's what Jacob drew up here, okay? Okay, so this would be our max, okay? Well, actually, he didn't draw quite like that. He drew it more like, this would be our min, right here, okay? But now, at this point here, and at this point here, the derivative's got to be 0 because our algebra says it's 0. So what does the function look like at these 2 points? It's going to look like this. You remember what x cubed looks like? You remember x cubed from back last year? Remember at 0, x cubed kind of comes in there and gets flat for just a second and then keeps going back down. That's what's got to happen here at 2, and it's got to happen again at 4. The function just flattens out and gets 0 for just a second, and then it keeps going up. Or just a second and it keeps going down. Okay? So to summarize what we've talked about here, all of these words on the next slide summarize everything you just told me. Everything you just told me. If the derivative is positive, the function's increasing. If the derivative is 0, the function is decreasing. If the derivative equals 0, then it's constant. If derivative is positive, it's increasing. Derivative is negative, it's decreasing. Derivative is 0, then it's constant. What does it mean to be constant? Function being constant. Doesn't change. So what does the graph of a function that's being constant look like? Just straight across. So this top part means the function's going to be going up, something like that or that. This second part means the function's going to be going down, something like that or that. And this third part means that the function's going to be constant. It's going to be flat. Now, how do we find those? Locate the critical points. What are critical points? Yep. Locate the critical points. That means find the derivative, set it equal to 0. Determine the sign of the derivative. That's with the sign line we just did. And then determine if it's increasing or decreasing by using these rules up here. So everything we talked about is summarized in that one sheet of paper there. But I did the other 30 minutes to hopefully get you to understand why it's that way. Does it make sense? That's far more important than you can follow the rules. I can make a computer follow these rules, and I'm not trying to make y'all computers. Got enough of those. So, do the next problem. You can work with somebody right next to you. Go for it.
Positive and negative.
The easiest thing to do is the quadratic formula here. It's going to be less time consuming for you to do that. If you want to do factor by grouping or the X factor, those things will work, but I think the quickest thing for you would be to actually use quadratic formula here. Four times 3 is 12. 4 times 5 is 60.
Just over 11.
Oh, no. I got two ugly numbers like that. Okay? 124 is 4 times 31. And the square root of 4 is 2. So what does that tell us? Ross, what are these two ugly numbers here?
Those are where the derivative equals 0.
Okay, so what are we going to do now? We know the derivative equals 0 with these two ugly numbers. We're going to make a sign line here, class. All right, 4 plus the square root of 31. Square root of 31 is about 5 something. 4 plus 5 is 9, and 9 divided by 3 is 3 something, okay? All right, and then 4 minus 5 is negative 1, right? Negative 1, about negative 1/3 something, so negative 0.3 something. So those are our two zeros. That's where our derivative equals 0. So now what are we going to do? Okay, so we found where our derivative equals 0, didn't we?
So now we have to plug in a number.
Plug in a number that's bigger than this, 3 point something. What's bigger than 3 point something?
3.1.
Or even 4. Wouldn't 4 be a lot easier to deal with, or 4 or 5 or something like that? So pick a number that's easy to deal with. What if we put 4 into the derivative up here? What are we going to get? 4 squared is 16 times 3 is 48. Minus 4 times 8, 32. Minus 5. I don't care what that number is, but all I care about is it positive or negative? Positive. So what does that tell you about the derivative from this point forward? Positive. So what does it tell you about the function from that point forward? It's increasing, okay? What's a number, easy number between 3 point something and negative 1/3? 0. Everybody see that zero's in there? So 0 minus 0 is 0, minus 5 is negative. So what's the function doing in here? Decreasing. Can you tell me about this point over here? Is it a max or a min? The function's doing what? The function's going down. So this point here we know to be a min. Okay? Let's see what's happening over here. What's a number smaller than negative 3?
-4.
It's negative 0.3. So we could do negative 1, negative 2, negative 3, whatever number we want there, okay? Negative 1 squared is 1 times 3 is 3. 3 plus 8 minus 5. Minus 5. That's a positive number. So what about this point right here? It's a max. Now, as Katie pointed out a little bit ago, we know it's a max, but we don't know what the coordinates are, or do we? Exactly. If we take this ugly number, plug it into the original function, we can figure out what the coordinates are. So if we asked you for the coordinates, you could figure it out. All right? Okay, good.
How do we know though? Why can't the second positive?
That's what I would do. If I get a quadratic and I can't look at it and tell that it factors, I'm going to do quadratic, guaranteed. I plugged in negative 1 because it's over here. 0.3. 0.3. 0.3. Okay, this problem's easier. This problem's easier. Do it. I want you to figure out where it's increasing, figure out where it's decreasing, and determine the maxes and mins. This problem's easier, I promise you. Increasing, decreasing, tell me where the max is, tell me where the min is. We've already done that. What do you, for the sign line part, the sign line's for the derivative, so you're plugging them into the derivative. Get in a better habit than your teacher is and label everything as you do it. Label that thing F prime so you won't be wondering later where on earth that came from. All right? Anything complicated about that, people?
This isn't complicated, but do we need to put the increasing
Depends on the question that's asked, because you're going to be asked all kinds of things, okay? This one, I kind of changed the rules on you halfway through it there. But just be sure you answer the question. That's far more, that's one of the critical things, because I've seen it countless times. Y'all work a problem, but you don't answer the question that was asked. So be sure you answer the question that was asked, okay? So increasing and decreasing, we can determine. Where a max, where a min is, we can determine. And all of that we determine by what we learned today, called the first derivative test, okay? Yes. Exactly, yes, always. Very, very seldom do I say that. But if the derivative is decreasing, the function is if the derivative is negative, the function is decreasing. The derivative is negative, the function is decreasing. Okay, we're going to skip over this because you've been using this already. You know what it is. Don't worry about it. Just keep using it. We're going to look at this problem because it's going to be a royal pain for you. I'm going to try to help you understand this. Find the relative max and relative min for the given interval. Again, don't graph it. Find the derivative, set it equal to 0, and then you can start trying, okay? That's what I got for my derivative. All right. So now when I solve that, I get the sine of x equals negative root 3 over 2. And you can't use your calculator on this problem, okay? We got to find x. When is the sine equal to negative square root of 3 over 2? Okay? She says this number here, which is what? No, 0, 3. 3. All right. She comes up with pi over 3. Okay? But she says negative, okay? So that pi over 3 is easy to come up with. Because if you're doing your hand trig, it's right here. The sine is 0. Yeah. Sine is 0, then that. So there it is. It's root 3 over 2. The problem is the sine is positive at that. Sine is positive root 3 over 2. How do we figure out where the sine is negative? Either you've memorized, and some of you have already looked it up on your unit circle. That's fine for now. But on the test next Friday, you can't look it up. Memorize. Do y'all remember this? All students take calculus. Y'all heard that before? Okay. What does this stand for? Yep. Cosine. Okay. So since we're worried about the sine, what two quadrants are we concerned with? The bottom two. 3, this one and this one. Well, pi over 3 is somewhere up here. How do we figure out where it is down there and down there? Y'all remember how to do that? Okay? All right, here's a simple non-math way to remember it, okay? It's going to have 3 in the bottom. It's going to have pi in the top. And it's going to be another number up there, okay? So pi over 3 is not it. Where do you think 2 pi over 3 is? Over here? Would that make sense? Since it's got to keep moving. 3 pi over 3. 3 pi over 3 is pi. Well, right there. 4 pi over 3 should be down here. So suddenly we've got 4 pi over 3 for an answer. 5 pi over 3 is 5 pi over 3 pi over 2? No. 5 pi over 3 must be over here then, so we've got another answer. Where's 6 pi over 3? It's 2 pi, so we're back to here. So we found our two answers there where it's negative. It's at those two places. All right? 4 pi over 3 and 5 pi over 3. How do I know those are the only two I have to worry about?
Because it's only between 0 and 2 pi.
Because it's only between 0 and 2 pi that we're concerned with here, okay? So now, have we answered the question? No. All we've done is we've found two places where the derivative is 0. So what do we have to do now, anyone? Sign line. We've got 4 pi over 3 and 5 pi over 3. Okay? And what is our only factor that we have? Sine x plus root 3 over 2. We can't have an equal sign. So sine x plus root 3 over 2. Wow. Well, what's less than 4 pi over 3? Pi. 0 is, but can we use 0? Negative because? Because it's what is right there and parentheses. So let's use pi. What's the sign of pi, anyone? 0. What's 0 plus a positive number? Positive. Function's positive. What's between 4 pi over 3 and 5 pi over 3? Ooh. Not quite.
4.5 pi.
Yeah. Do you know what 4.5 pi over 3 is without using your calculator? Okay. Remember back up here. 4 pi over 3 was right there, wasn't it? Would y'all agree with me? 5 pi over 3 is over there. So 3 pi over 2. What's the sign of 3 pi over 2? Negative 1. Is this number bigger or smaller than 1? Smaller. So negative 1 plus something? Negative. What's bigger than 5 pi over 3? 2 pi. Can we use 2 pi? No. It's bigger than 2 pi. 7 pi over 4.
It's less than
7 pi over 4 is 1 and 3/4. This is 1 and 2/3. Yeah, 7 pi over 4 would work. What's the sign of 7 pi over 4? It ends with a 4, so it's root 2 over 2. Is it positive or negative, though? It's in the fourth quadrant. Negative root 2 over 2 plus root 3 over 2. Negative root 2 over 2 plus root 3 over 2. Which of those numbers is bigger? One of them is. Square root of 2 is 1.4. Root 3 is 1.7. Maybe if I put these up here for you. Root 1 is 1, right? Root 2 is going to be bigger. Root 3 should be bigger because root 4 is bigger. So this one's bigger than that. Positive minus a negative, what's this going to be? Where's the max? Okay, there's your max. Where's your min? Where's it increasing? Why is it 0 and not negative infinity? Remember, we were only looking at this between 0 and 2 pi. So it's increasing from 0 to 4 pi over 3. And from 5 pi over 3 to 2, it's decreasing in here from 4 pi over 3 to 5 pi over 3. Yes. Probably, yes, we're going to do some more like that. Excuse me, yes, you're going to do some more like that, okay? All right, here is your, now, what are you turning in? What are you turning in? You're turning in everything after your turn on this, okay? So the stuff that's due tomorrow is everything after your turn. You don't have to do this one, which comes before your turn. You don't have to do this one, which comes before your turn. You just start on this slide right here. This is problem 17. There's probably 9 or 10 problems if I'm guessing. Yeah, well, remember, we've got time tomorrow to work. All right? It's due tomorrow night, yes. It's due tomorrow night. So you've got the next period to work on WebAssign and this. You'll have time tomorrow to work on this. And then we'll talk about the second derivative test tomorrow for just a brief period of time. You'll have some time to work on it going into Wednesday. That stuff is going to be turned in, okay? Still okay for you to go to the softball game? Yes, absolutely. Yes, you may go to the restroom.